Hi, BC Calc. So in this screencast, what you're going to get here is a first taste of what is called integrating. Okay, and I'll certainly define this vocabulary word for you. Those of you who are from AB last year, your role right now is to be your TIC best friend's biggest cheerleader as they experience going quote unquote backwards for the first time. And I also welcome your feedback about how I present this new idea because I'm always looking for feedback for just how to, tell the story of the calculus better. So, all right, everyone. So this is largely focused on the TIC students because for them this is a new idea. It's also an incredibly important idea, and there's going to be many ideas here. I also chose to do this lesson in a way that will make us all write everything out. I thought about doing a handout in which you can just fill in the blanks, but there's so many ideas here that kind of really warrant just that muscle memory and your hand writing it out so you can really emphasize these ideas. Okay. All right. So this first sentence here should not surprise or disturb any of you. Okay. The derivative of sine x is cos x. The statement that is also analogous is saying that the antiderivative of cos x is sine x. Okay, so when we talk about the antiderivative, we are in effect talking about quote unquote going backwards, right? If you're asked for the antiderivative of cos x, you're asking for what function has a derivative that is cos x, and of course the answer here is sine x. I'm going to make a very important change here. I use the word the right here. It should not be the. It should be an. And I'm purposely writing that out. The reason why we say an antiderivative of cos x is sine x is because of a reason that I alluded to in my previous screencast. This could be sine x plus any constant. It could be sine x plus 3, sine x plus ln of 15. The point is, sine x plus any constant would have a derivative of cos x. So if you're asked the question, how many antiderivatives of cos x are there? There are actually infinite antiderivatives because there are infinite ways that I can add a constant to sine x. So to make this statement even more accurate is to say this, okay? The family of antiderivatives. The family of antiderivatives of cos x is sine x plus c. So here's another idea. Family of antiderivatives. And here's the first difference between going quote unquote forwards and going quote unquote backwards. Last year, when we talked about differentiating, taking the derivative of sine x is cos x, there's no adding of c here, right? So differentiating has an output that is singular, 1. Anti-differentiating has an outcome that is infinite. It is a family of antiderivatives. We have to account for that infinite possibility because there are infinite different constants. Okay? So we could say the family of antiderivatives of cos x is sine x plus c. We will also introduce this word, this phrase, the indefinite integral. The indefinite integral of cos x is sine x plus c. Because when you are asked what the indefinite integral of something is, that is saying the same thing as what is the family of antiderivatives. These two phrases are synonymous. The indefinite integral of cos x is sine x plus c. Now, symbolically, we have, without even thinking, I bet, you would say, if I ask this, d by dx of sine x equals c. Oh, c, silly. Cos x, right? Symbolically, this sentence right here is translated mathematically here. So the question is, how do we ask this question mathematically? Okay, and again, this question is the same thing as this question, right? Really more, I can't even say formally, because these are both formal ideas. All three of these actually are the same with this, with that, with the starter of the and. How do you say those three sentences symbolically? Here it is. Okay. The indefinite integral of sine x, oh my goodness, I just went backwards, excuse me. The indefinite integral of cos x equals sine x plus c. Now, this is very important, TI, so listen very carefully. When you have this sentence written mathematically, there is always a dx tagged onto it. The significance of this, which is called the dummy variable, okay? For right now, I'm just going to tell you, we're just going to stick it in and write it. What it means nothing to you right now beyond you must write it. You must write the dummy variable of dx, and you must always write it so that the dummy dx is a factor of what you are taking the indefinite integral of. So let me give you some vocabulary here. This function, which we are trying to anti-differentiate, that is called the integrand. The integrand is that thing that you're trying to find the family of antiderivatives of. This symbol right here, a lot of people say it looks like an S. It is an S. That symbol is the integral symbol. Okay? As far as the dummy variable, boy, the dummy variable has a huge, important story. We are not ready for it yet. So all I'm going to do is tell you right now to write the dummy variable there. Here are the two things you need to know right now. And ladies and gentlemen, I almost never tell you to just do math this way just because. The reason why I'm not giving you the full story of the dummy variable is because we don't have enough quite of an understanding of the indefinite integral for me to fully explain to you. You will in about a week. All you have to know right now is the dummy variable number 1 must be always expressed as a factor of the integrand. What that means is, everybody, okay, what that means is the following. It means that the dummy, the operation right here, unwritten but understood, should be multiplication. Okay? You'll never see something like this. The indefinite integral of cos x plus dx. That is nonsense and means absolutely nothing. Okay? The second point I want you to tend to right now, and this is it, is that the variable, that x right here, the x part, the dx, okay? The variable of the dummy must match the variable of the integrand. Okay? What that means is you will never see something like this, the indefinite integral of cos x dy. Okay, you will see that next year in multivariable calculus, but you will never see something like this year for us. Okay, this actually does mean something later on. For right now, when you see this expression, it's really important that you read this in your head the correct way. The way you read this and the way you say this is this way. It's like this. You read this as the indefinite integral of cos x dx is sine x plus c. Okay, notice something. When you read an indefinite integral, or when I call you and I say, Prayag, what does number 5 say? Yes, you do say the dx, all right? That's how you say it, the indefinite integral of cos x dx. So, ladies and gentlemen, and really for TIC folks and AB people, I don't want you to feel bad, but I'm particularly tending to my TIC students here. This moment is huge, all right? You are taking your first steps into the second branch of calculus called integral calculus, okay? Integral calculus is the calculus of, one, the very basic operation of just anti-differentiating, but also you're going to embark on all the applications of quote unquote going backwards, right? If you think about differentiating and taking the derivative, you spent, quite some time learning about the power rule, the chain rule, the quotient rule, product rule. Well, guess what? All of those derivative rules have corresponding anti-derivative rules. But what's the first thing you did when you took the derivative? The first thing you did was you learned some basic derivative rules and you practiced them. After maybe a couple of days of that, then you went into the chain rule. Well, so it goes here. We're going to just practice first with just seeing if we can evaluate the following. Let's practice together. Okay, let's evaluate the following indefinite integrals. The indefinite integral of e to the x dx, what does that equal? So you're asking yourself, what function has a derivative that is e to the x? Maybe you're pretty sharp right now and you'd recognize, oh yes, it's e to the x and then plus c. Don't forget, we have to always include the plus c because this indefinite integral right here is asking for, again, the family of antiderivatives. You always have to add on the plus c, plus c, plus c, plus c. Maybe it'll help if I just do something like this. I have no idea if that helps. That is just embarrassing. Never mind. Delete that. Okay? All right, let's take it up a notch. Ready? Question number 2. How about this one? And again, AB, if you're with a TIC person, you're going to put your hand on their shoulder in a figurative, symbolic way because you're 6 feet away at least. And you're going to tell them, I know this feels very uncomfortable, but guess what? You totally have this. Okay, now look at this. I want to make sure that the integrand, look at that, the parenthesis, is a factor of the dummy, the indefinite integral of the quantity x cubed plus 1/2 x dx. All right, well, let's see. We're going to use here, everybody, let's think about it. Let's take it term by term. The derivative of what will give you x cubed? Well, I'm thinking to myself that I want to increase the power by 1, right? And then you want to think to yourself, okay, if x to the 4th is the antiderivative, when I take the derivative of x to the 4th, everybody, I'm going to get 4x to the cubed. The coefficient here is 1. So I want to make this 1/4 x to the 4th. Everyone okay? Plus, go ahead, try the power rule now in reverse with 1/2 x. This is x to the 1st, right? Let's see, I'm thinking I want to add a power, the integer to the power x squared. Okay, and then when I take the derivative, this will be 2x, but I want the coefficient to be 1/2, so I'm looking at, oh my, 1/4 x squared, right? And then here is my plus c, antiderivatives. All right, you want to try something juicy? Well, you don't really have a choice, do you? I'm just talking, you can't even argue with me. How about this one? Square root. The indefinite integral of the square root of x dx. I'm going to give you a hint, everyone. Write it like this. Indefinite integral of x to the 1/2 dx. Okay? Give it a thought and then replay me when you are ready for the answer. But don't give up so quickly. Go ahead, pause me and try it out. All right, you ready? Here I go. Let's see, I'm going to add 1 to the power. Add 1 to the power, I get, x to the 3/2. And I'm liking what I see, because if I use the power rule here, I'm going to have 3/2 x to the 1/2. But oh no, I want the coefficient to be 1. Oh ho ho, look at this. 2/3 x to the 3/2 plus c. Okay? Here's question number 4. Ready for me to go all out? Here we go. The indefinite integral of the quantity 1 over x plus secant squared x plus, oh boy, what should I do? Plus, oh, I know, here we go. Sine x dx. Okay, try it on your own, then replay me. All right, so I bet some of you, when you looked at 1 over x, some of you may have rewritten that as x to the negative first and tried the power rule, and you would have found yourself stuck because you'd be dividing by 0 somewhere. And I'm going to ask you this. What is the derivative of the natural log of x? It is indeed 1 over x. There's my first term of the antiderivative. Plus, let's see, secant squared x. The derivative of what is secant squared x? Yes, indeed, it is tangent x. Okay, plus, let's see, the derivative of what is sine x? Well, let's think about it. The derivative of cos x is sine x. That means the derivative of, wait a minute, what did I just say? The derivative of cos x is negative sine x. That means I want this term to be negative cos x because the derivative of negative cos x will be sine x. And don't forget my what, everyone? Do not forget my plus c. Okay, now go with me if you would. Let's go to your homework. Let's just do some together. Come with me there. Let's see, I think I have it up here somewhere. Where is your textbook? There it is. All right, so tonight I assigned 15 through 29 odd, okay? I'm gonna give you a little hint. If you look at a question like number 19, actually, you know what? Let's look at number 20. A hint for some of these is sometimes you may want to use some algebra to simplify the integrand first. So let's take a look at number 18 and 19, okay? Number 18 and 19, I'm gonna go back and write these down over here. 18 and 19. It says the indefinite integral. This is number 18. Notice I'm not taking a homework assignment away from you, a homework problem away from you. 18 is the indefinite integral of, what was it again? What did it say? 1 plus x squared times 2 minus x. Good. 1 plus x squared times 2 minus x dx. Okay, so at this early juncture, you know, we're not doing anything like the chain rule in reverse or the product rule in reverse or the quotient rule in reverse. Our first taste of anti-differentiating, or our first taste of taking the indefinite integral, is just recognizing derivative rules in reverse. So what I'm going to do here is FOIL it out. FOIL out the integrand. I'm going to get 2, let's see, minus x plus 2x squared minus x cubed, okay, dx. And then if I do that algebra, I notice here my integrand now is in a place where I can just anti-differentiate term for term, okay? Go ahead and you try it on your own and then replay me for the answer. Here it comes, 2x minus 1/2 x squared plus 2/3 x cubed minus 1/4 x to the 4th, and then what's last? Plus c, okay? And those of you, and I know the first day or two, you will feel like you're putting your shoes on their wrong feet. It's gonna feel so strange, but trust me, you'll get the hang of it, and before you know it, it'll be second nature. Let's do number 20. Where's 20? 20 is 1 minus t cubed all over t cubed, okay. 1 minus t cubed, the indefinite integral of 1 minus t cubed all over t cubed dt, right? Remember how I said that the dummy always matches the integrand, the variable? All right, this is number 20. Go ahead and you try it and see what algebra you can do first to simplify this integrand. Oh, I just started talking as I went. Oops. Oy, ay Dios mío. T to the negative third minus 1. Okay, dt. All right, pause me and try on your own. Okay, power rule in reverse. I'm going to add 1 to the exponent. I get -2. And I want the coefficient here to be -1/2, so that when I take the derivative here, I'll end up with a coefficient of 1. Minus, what's the antiderivative of 1? Well, it's just T. And then what do we not forget? Plus C. All right? And with that, everyone, you should be well poised to finish your homework. Great job, and I will see you tomorrow.